All right, so today you should have picked up the iStep digital assignment, Khan Academy pink slip. You just need to get those 5 assignments done by March 2nd for your digital assignment for this class. You also should have picked up the note sheet, and we're going to jump right into that note sheet to get you through some basics of adding and subtracting polynomials today. This is the beginning of this next unit, which will be about a 2-week unit, so pretty short and sweet, and we're going to be focusing on adding, subtracting, multiplying polynomials. Here's the schedule, and so for today you have about 50 minutes to complete this. Again, your Khan Academy pink slip, that is what you should be working on to get filled out throughout this week on Khan Academy. You also have week 7 homework by the time you leave today, so make sure you are spending time this week getting homework done. So this unit is Unit 6, it's polynomial operations. We are going to be adding, subtracting, and multiplying polynomials. So that's the term that you probably are least familiar with out of those. Hopefully you know how to add, subtract, multiply at this point. So let's do a little introduction to adding, subtracting, multiplying, and why we might want to do those things. And we're going to play a little game. It's called speed counting. All right. So I know this is a video, so you could pause it and cheat. Don't do that. Play the game as is. Here we go. There's 3 rounds, and you're just going to count how many fruit there are. So round 1, go. Oh, did you have enough time? If not, that's okay. If you have any guesses, you can think to yourself about the guesses, but you're just trying to count how many of each fruit, right? So how many of each fruit there are. Here we go, round 2. Ready? Go. Did you have any luck? Maybe if you go back and you can check your answer here. But otherwise, just keep moving forward, and let's go on to round 3. So round 3, how many of each fruit are there? Go. Do you have enough time? Maybe you did that time. So if you notice in that last picture, that last round, it kind of clearly told you exactly how many fruits there are. If you go back and watch that first round, there's the same amount of fruit on the page each time, but it's organized a little bit better each time, leading up to this image, which tells you exactly how much fruit there is. And that's kind of the idea of what we're working on today, is how can we organize the things that we're dealing with mathematically into the most simple form to help it be easier to communicate. Right? So that's the big idea here. Let's start with a little bit of terminology, right? Establish some vocab terms here, and that comes to the term polynomial. So this is where your notes begin. So polynomial, get these copied down, is an expression of any number of terms. A monomial, right? So polynomial is kind of the general term. Monomial is a more specific type of polynomial, and it has one term. And here are a couple examples. Notice these monomials, they all have one term. Notice this one, the y has a little 1 there. You could write it in. Notice this one, this is a monomial. It looks like it has a lot of different things going on, but this is all one term. Here's an image to help you remember monomial, right? Remember the root word mono, not the sickness, right? So mono meaning one wheel. Binomial, if you had to guess, you guessed correct, right? 2 terms. So here's some examples of binomials, right? So think about the difference. The difference between a monomial and a binomial is right here. You can see there's some addition specifically in these cases. There's an addition sign between the 2 terms. So for example, negative 2x is a monomial and positive 1 is a monomial. When you put them together, you get a binomial. Same thing with 5xy and z squared. Take those 2 things individually, they're monomials. Put them together with an addition or subtraction sign, and they're binomials. And of course, bicycle, right? 2 wheels. And trinomial, if you had to guess, right? 3 terms. And then here are a couple examples of a trinomial, which again, it looks like in that second one, each term has quite a bit going on in it, but those are 3 monomials put together to create a trinomial. And again, it comes down to the sign that is connecting those terms, that is between. Right, notice back up here with this this monomial, that is a monomial if we were to write it something like negative 4a plus bc squared. Now all of a sudden that is a binomial, and that would belong down here. But originally this was a monomial. Okay, so let's go ahead and take a look here. Oh, there it is. There's the tricycle. Right, 3 terms, 3 wheels. Get it? Move. So in your notes, we need to fill in some blanks here, and we need to think about like terms. And you have seen, and we've dealt with like terms before today, but we've only looked for like terms as they have the same variable, right? So like terms are things that have the same variable. Well, yes, but they also have the same exponent, and that's something that we hadn't really focused on yet. But they have the same variables and the same exponents. So if you notice in each of these tables here, we have sets of like terms, and you can make up your own to complete the last box in each of those. So for example, mine is 13x. For that second box, that second column, notice none of those have variables. So as long as you write a number that doesn't have a variable, it's like term. In the third column, notice the exponent, the variable is y and the exponent is a squared. So you need to make sure your term has a y squared in it. And then those last two, here are a couple examples. Notice in that last one, if I had written something like 13ab squared, those exponents don't quite match, right? This exponent is technically a 1, whereas this one I wrote was a 2, so that one would not work. Okay. Just going back real quick to highlight in that first column, the green column, the variable x actually has an exponent, and it's an exponent of 1. So since it's not written there, it's like another one of those hidden ones, right? If it's not written there, then there is a 1 there. We just don't write it because we're assuming that it is as we imagine, right? It's a 1. Okay. So let's keep moving here, and I want you to take a moment and pause the video and go through each column. This time they are going horizontally. So in column A, find the thing that is not like the other. So find the term that is not a like term. Okay, so check your work in each of these cases. Those are the terms that are not like terms. Again, they have to have the same variables, but also the same exponents. So like in C, the exponents are 2 instead of a 1, like they are in the rest. Okay, so just be careful. Have to have the same variable, the same exponent, and then that makes them like terms. We have been combining like terms for a while now, right? When we simplify expressions, that is combining like terms. We have to do a little distributing first, and then we have like terms to combine. And that's exactly what we've been working on this whole year so far throughout. And when we solve equations, same idea. In the process of solving equations, we've combined like terms, right? After we distribute on the same side of the equal sign, we try to combine things together so that our equation is a little bit easier to deal with. So we've been combining like terms, but it's been in ways that only deal with one variable at a time, whereas now we're going to be dealing with multiple variables. So at this point, we're going to work a little bit on adding and subtracting polynomials, and we're just going to get right into it here. So we're only going to focus on adding and subtracting today. And what I want to focus on, though, is that you're identifying what operation we are being asked to do. And in this case, we are being asked to add. So when we are being asked to add, all we have to do is add or subtract the coefficients. Add or subtract the coefficients. Let me try that one more time here. And then the variables do not change. So that means I have to identify the like terms. So for example, I have a negative 2x squared and a negative 7x squared. Those are like terms. I have a 5x to the third and a 1x to the third. And I have an 8x to the fourth and a 4x to the fourth. Each of those things I circled in the same color have the same variable with the same exponent. And once I've identified these, I can now just go ahead and add them, right, or subtract, just depends on the sign, those together. So negative 2x squared plus negative 7x squared is negative 9x squared. The next one I'm going to do is the x to the third term. So that's a 5 plus a 1, so that's 6x to the third. And the last two are the 8 and the 4, so 8 plus 4 is 12x to the fourth. And so now I have combined like terms, and at this point I notice none of the terms have the same exponents. Right, so none of those have the same exponents, so that means none of these are like terms anymore, so that's it, I'm done. Now, here's another way that we could write our answer, and what I want you to notice and get in the habit of is to write your answer in descending order of the exponent. So notice I rewrote those in order from largest to smallest, and that is something that you need to do. It just makes it easy to check work, right, with another student, but it's very clear in terms of the order then. Okay, so just make sure you keep the sign, right? So notice that negative 9x to the second still is negative down here, right? The order, as long as you keep the sign with the term, the order doesn't matter, but the way you write your final answer is from largest to smallest exponents. Okay, so in Number two, I want to first start by noticing that we are dealing with subtraction. And the way we are going to handle this is we are going to do keep, change, change. So keep, right? So keep the first polynomial, change the sign, and change the sign of everything in the second polynomial. So in that first parenthesis, nothing changes. It's going to stay negative 6 minus 7x to the third minus x to the fourth. I'm going to change the subtraction to addition, and I'm going to change the sign of every term in the second parenthesis. This is where you want to be careful. And now that I've changed it to addition, I can now just identify like terms. So again, I have a negative 6 and a negative 7. I have a negative 7x to the third and another, let's see, that should be actually, I just noticed I made a mistake here. This should be a negative 7x to the third as well. Right here. Struggling with my pen tools here. There we go. And then I have I'm going to put a 1 in here. So I have a negative 1x to the fourth and a negative 6x to the fourth. Notice how I'm including the signs when I box in or underline or circle those terms. So now if I go back and I combine like terms, I'm going to go ahead and start. So notice my answer starts with the highest exponent. That's a way for you to avoid rewriting it. To rearrange them in order, start with the term that you know should go first. So I've got the negative 7x to the fourth and then minus 14x to the third. Notice those don't cancel out. And then plus 1. And there we go, final answer. Let's do a few more here. Again, starting with subtraction, we're going to change that right away to addition. And everything in the first parenthesis stays the same. And in the second parenthesis, everything changes sign. So it's now positive 7xy minus 6x to the fourth minus 7xy to the fourth. And now we can go back through and identify like terms and combine them together. Now notice these terms have x's and y's, so the order here is a little bit trickier. We can still identify like terms. Right, negative x to the fourth, negative 6x to the fourth, 3xy to the fourth, negative 7xy to the fourth, and let's do a triangle. However you want to identify those like terms, do whatever you need to. So now we're going back and we are going to add or subtract those coefficients. But again, notice this whole time the variables did not change. So when I combine those like terms, I still have an x to the fourth, I have an xy to the fourth term, and I have an xy term. Those didn't change. The exponents of those terms did not change. So notice this one has both subtraction and addition. It's the subtraction that I want to change. So I'm going to change that to addition. And again, the signs of the second polynomial all change, but that's it. So I'm just going to rewrite the middle polynomial and just kind of scratch off this one here. And then again, I'm just going to go through and combine like terms, or check for like terms, and then combine. So we've got a 5p to the fourth, a 7p to the fourth. We've got a -4 and a +7. And then notice the two remaining terms are not like terms. They have a different variable, or different exponent rather. So now when I go ahead and combine like terms, you can pause the video and do that first if you'd like. When you combine like terms, and put them in, again in order, descending order, those two things that are not like terms, they just get brought down. Right? They get brought down in the answer without being combined. So there it is, final answer. Moving on to the last couple questions. At this point with polynomials, we can think about perimeter, just like we have been with word problems. And thinking about perimeter, we've got two shapes here. Finding perimeter is just adding up all the sides. And so you could probably go through and know that, okay, if I'm going to add up all these sides, then I just need to find all the like terms to add together. So for example, there are all the x's, all of the numbers, add those up. Another strategy you could use is just to take each expression. So notice they're kind of rewritten down here, and just stack them together, lining up with the like terms. And then for some of you, that might just make more sense to add up down the line and get 17x plus 15. Same idea with the triangle. Again, you could stack them and then add them up, and we end up with 5b plus 13. I want you to pause the video and try this one. Find the perimeter of the rectangle, and then check your work. Okay, so I'm guessing a lot of you did this. So knowing that this is a rectangle, opposite sides are the same. So that means now, if you know that, then you can take and add up all the x terms. We get 3x, 3x is 6, 7, 8, 9, 10. So 10x, and then all of the numbers, we get 4 plus 4 is 8, but then -1 and -1 is +6. So 10x plus 6. Thinking back to the perimeter formula that we've seen a lot in our word problems, I want you to write this on your paper to have a different way of doing this, but we could do this in a similar way that we use the perimeter formula and substitute, right? So if I have two expressions, right, so originally we had 3x plus 4 and 2x minus 1, well, I could take and I could plug those, I could substitute those in for the L and the W, and then I have an expression that I could then simplify, right? So distribute, and then combine like terms. Okay, so same answer, just a different method or technique, right? So there is your notes. At this point, you may have a little time to work on Khan Academy. So I would begin Khan Academy, and then by the end of class, you should have week 7 homework. Right, so that's really the big thing is this week is making sure you're spending time on homework. Khan Academy, again, the digital learning. Make sure you bring that checklist. That's going to be due on Monday, right? So next Monday, focusing on these 5 assignments. And then just remember long term, making up any missing work or retests. So if you have, if you're planning to do the systems retest, you need to be working on getting that ticket done and as soon as possible. Okay. All right. So that is the end of our notes today. Get to work on the rest of the things and have a good day.